Good afternoon, my fabulous chemistry students. Video number 5. Today we delve into equilibrium. We need to know the 3 different types and what, of course, equilibrium even is. Okay, so we did talk about forward and reverse reactions a little bit in the potential energy diagrams. Today we're going to delve a little bit deeper into that specifically. And we need to know that it is the rates, and it doesn't say this on the board, but it is the rates of the forward and the backwards reaction or reverse reaction that give us equilibrium if those rates are equal. Okay, so equilibrium and rates, you see how rates is in there. This is the most important piece. So why is it not clicking? When the rate of the forward reaction equals the rate of the reverse reaction in a closed system, then I can have what's called equilibrium. Okay, and it is the rate that is important. Okay, we represent it with these double arrows instead of just a single arrow, because that lets me know that there's a forward reaction going on and a reverse reaction going on at the same time. Okay, it is dynamic, which means it is changing and fluctuating. The forward reaction does not stop. The reverse reaction does not stop, but the concentrations will stay constant, which makes it look like the reaction isn't happening. Okay, so the concentrations are constant. The reaction is going, but there is no change in concentration anymore. Whoopsies, sorry about that. So now we need to define in terms of reactant and product concentrations. Okay, so define equilibrium. The concentration of products and reactants. Sorry, I'm getting pretty sloppy. Stays constant. Okay. Define equilibrium in terms of forward and reaction rates. The rate of the forward reaction equals the rate of the reverse reaction. Oops, that's an N, not a W or an M. I like to do capital R, little x, N for reaction, so you know that's a little bit of shorthand. Okay, but it's the rate. There are types of equilibrium. They occur, we need a closed system, number 1, and it's all about the rates, right? So a phase equilibrium happens during those phase changes. We did those phase change diagrams that looked a little bit like this. Remember? And here's where that phase change happened. And so here is solid and here is liquid. And in between, there is a phase equilibrium between solid and liquid going on. Okay? And so this kind of depicts it for you pretty good. Solid to liquid, liquid to solid. They're going back and forth, back and forth, back and forth, back and forth. And all of a sudden, bam, we're liquid. Same with liquid and gas. I go from liquid and I'm in this equilibrium with liquid and gas and liquid and gas, liquid and gas. And eventually all the potential energy stops changing my phase is changed, and boom, kinetic energy changes again because I'm now a gas. Solutions at equilibrium, at the saturation point, the rate of dissolving and the rate of crystallization is the same. And this is a good one for our solutions unit we just had. If I have my beaker and I have my water and I kept putting salt in, right, NaCl, and I kept stirring and stirring and stirring until all of a sudden there's these little salt crystals on the bottom that don't dissolve. I've saturated the liquid. Because there's solid on the bottom, I'm not super saturated because it's not putting any more into solution than should normally be. Now an equilibrium system happens because as this particle now dissolves, another particle that's in solution is going to crystallize out. And it's going to keep happening and happening and happening. And that is another form of equilibrium. Okay? Chemical equilibrium is the bulk of this unit. The rate of the forward reaction equals the forward rate of the reverse reaction. The rate of breaking bonds equals the rate of forming bonds. And we tend to see diagrams like this. Sorry, it's a little bit blurry. Excuse me. But if this is, you tend to see them and they do this. And then this one does like this. And they usually end up parallel and not touching, whereas in this infograph, they are touching. But this is where, this side here is where my equilibrium is reached. I'm in equilibrium here. And then here, this is what we call the kinetic region. Whoops. Region. That's a G, not a Q, sorry. Region. Okay, the kinetic region, the concentrations are actively changing. Okay, and then when I equalize out, and the reactants start reacting, so the reactants are up here, they start reacting, and they all of a sudden they're in the product. And this is another reaction or reactant that's being used up, and all of a sudden, boom, and here we go. Now I'm in a equilibrium. Okay, so there's chemical equilibrium. Now we know a little bit about equilibrium. It goes both ways. There are three types. Most importantly, part of equilibrium is the rate of the forward reaction equals the rate of the reverse reaction. See you guys all in class.